This episode is sponsored by Micro Focus and the LoadRunner Solutions family. That includes LoadRunner Professional, Enterprise, Cloud, and Developer. You know, performance matters. Did you know that LoadRunner Solutions have the largest community of practitioners in the world? Join that community at community.microfocus.com, scan the QR code, and check out the LoadRunner family page on performance engineering, as well as their YouTube playlist that we've got links for in the show notes on smcjournal.com as well as YouTube. Hey everybody, you're watching the SMC Journal podcast. This is the show that's all about systems engineering, DevOps, observability, and all things enterprise IT today. I'm Scott Moore, your host. Thank you for joining me. Can you automate reliability? Well, what am I really asking here? We hear a lot more in the industry about reliability and resiliency. We have site reliability engineering now, and performance plays a role in there, but also just making sure that things don't go down under point loads. And I can honestly say, if I were an SRE full-time and I wanted to reduce as much toil as possible, I might ask the question, can we plan for that? And can we automate the response for that? It's one thing to monitor that with an observability platform and know that it's coming, but what can you actually do about it? Well, you can sit there and wait around for something to happen and react to it, or you can be proactive. So I asked that question myself. Can you automate reliability? And I came across this interesting article on TechCrunch about a company called FluxNinja. Now, they were announcing a product called Aperture. It's an open source product, but this company focuses on flow control and for web applications, for any kind of cloud native applications. So it says here, and this is very recent, that FluxNinja emerged out of stealth mode to announce their first open source flow control and reliability management platform. And here's what kind of got my attention. Over the last decade, cloud computing platforms have enabled online businesses to reach massive scale, but we still see these sudden spikes on Black Friday. So what can we do about that? Or, how can we prevent these crashing apps? And if we're on a DevOps or an SRE team, we want to automate that response if we possibly can. Thus, this is the problem that they're trying to solve. So if you think about it in a elementary way, it would be like if you get on GitHub, you open up your own repo, and then you start pushing your local code to GitHub. You can only push so much before GitHub starts pushing back and saying, hey, you're reaching some of your limits here. We only accept so many requests per second, so we're going to start rate limiting you on that. And then there are secondary rate limits that you can achieve. So sometimes you have to take a code push and you have to put like a half a second or a second between requests so that you don't hit those limits. And sometimes you have to go to higher paid tiers to get better boundaries around those rate limits, or higher boundaries, I should say. Well, that's the kind of thing that we should think about doing. And more than just that, that's just a simple way of looking at it. Those are the kind of responses that we need to do when we get this point load traffic happening on our application and we're in the cloud. And what tools do we have available? We have the way to see what's happening and trace what's happening and know what's happening, but in the thick of things, you need to be able to automate your response to that. So I thought this was a very unique thing that I had not heard of before, and it's a very good article. And so I wanted to bring on the co-founder and the CEO, Harjot Gill of the company, to talk about what this is and how does it actually work. So let's bring him on now. Harjot, welcome to the SMC Journal podcast today. Good to have you.
Hey, Scott. Glad to be here.
So I'm looking at FluxNinja and I'm curious about it. I had heard about you, and the topic of today's show is, can you actually automate reliability in the enterprise? And I think you might be a person that would have the answer to that. So tell me about you and about FluxNinja.
That's great. So I'm co-founder and CEO of FluxNinja. So what we are building is reliability automation solutions for cloud native applications. And the whole idea is, how do you protect, recover, and prevent outages, especially like applying control systems principles to automating a lot of these tasks, right? And prior to FluxNinja, so I've been an entrepreneur for a while. Like prior to FluxNinja, I did an observability startup, very early days of observability, called NetSil. it was like listen spell backwards. And in that startup, we kind of built an observability layer that could take a network centric approach, understanding how your microservices were performing and so on. And Flux Ninja is kind of continuation of that work over the last so many years.
Okay. So tell me about the idea of flow control.
Yeah, that's a great question, right? So when we started this company, like as I said, like we have been in this space for a while, and we were talking to so many practitioners, site reliability engineers specifically, on what actually happens when they see these complex failures, and why are these applications so much prone to failures. Like we have all these like invested investments done in Kubernetes and very sophisticated cloud platforms, which have made it easy to deploy sophisticated microservices and so on. But still, like these applications are becoming more and more fragile. If you look at like Black Fridays, uh, like a lot of like well-known websites go down because of overloads, and even without even like predicting these loads, like these failures just happen from time to time. Like cascading failures are more and more common than what we think, right? So we said, okay, like if we have to solve for reliability, this is a very different battleground than it was 20 years back, right? So it's like going from a tank battle to an air battle, right? So you need to have sophisticated solutions to solve for it, and the journey we think begins with flow control. And I will talk more about like what flow control actually means. For a lot of for your audience, this might be like a new term, even though they might have heard of this in the context of networks, but we have to understand in the context of a very API centric world, and with lots of features, microservices, right? At a very high level, like if you look at all these applications, they're all client server architectures, right? So you have some requests coming in, you have to serve the response and respond back to the user. And these are very similar to like how, let's say, restaurants work. Like you have orders coming in, you have to prepare food in the kitchen and serve the dish and so on. And just like and interestingly, as you go microservices architecture, your function calls that used to be in the monolith, let's say Java application, are now network calls, right? So your function calls are increasingly being replaced by API calls over the network because of decomposition and autonomy and so on. And that's where flow control comes in, because as you have a now you're dealing with network here, and when you're dealing with a network, it's a queuing theory. So the queues are something you have to deal with. You have to deal with these queues potentially blowing up and causing cascading failures throughout the application, right? So what flow control does is it applies all the systems thinking, like scheduling, network scheduling, and those kind of principles, like who gets prioritized, and when you are under constraint or a failure, uh, things like token buckets, like you have to think through all those things, rate limiting. So flow control like is variety of techniques that can protect an application or prevent those failures from becoming large scale failures.
So, how are enterprises trying to accomplish this today? Are they just doing some manual things, setting some things up? Or, I mean, how do they try to accomplish this now?
Yeah, it's very challenging right now. So they're doing a variety of techniques, and none of these are very, very effective. And that's why, as I said, like we're fighting a tank battle, whereas the battleground has moved. Like that's why we're seeing so many failures. One of the things they're trying to do is at the load balancing level. They will apply very precautionary, rudimentary rate limits, but rate limits really do they can prevent failure to some extent, but still the failures will happen because your service capacity is not the same thing as per user rate limits. You could still be complying with those limits while you could be crashing on the back end. And the other things customers do is, like, let's say, auto scale, right? And now the auto scale has few issues. Like first of all, it takes time. Like if you have, let's say, a certain spike coming in, even if you had done very good capacity planning, it takes time to hydrate new instances as they come up. It's not very straightforward to even scale things up. And secondly, it's cost prohibitive. Like sometimes you might have like very transient spikes, and it's not like you have to over provision your infrastructure by and spend millions of additional dollars just so that you can absorb all that load from unnecessary traffic, which could be originating from bots or scripts. So because you have to do prioritization, right? So in any application, there are many pathways which are high priority. Like maybe your checkout API is much higher priority than, let's say, serving recommendation. So in order to build fault tolerance in a very cost effective manner, you have to think about graceful degradation, right? So today, like, all these things are very, very ineffective. Like, people have tried circuit breakers, which I have learned are very, very hard to configure. Like, you actually never know the upper limit of what an application can take, because you're dealing with very elastic infrastructure. Your instances scale out and scale in, and the technique you have to do is a closed loop system. So if you look at the FluxNinja architecture, what we have really done is observe, analyze, and actuate. So we're building on top of observability a closed loop system that's can taking constant measurements to understand whether you're violating your service level objective or an SLO, tracking those violations, and then bringing your entire application back to a stable state by applying flow control or some proactive scaling and so on.
So the way that you accomplish this is you've got these Aperture, that's your product. You have an agent, and it operates, if I understand it correctly, like a sidecar. Is that?
That is correct. So unlike Netzel, our previous startup in FluxNinja, like we are actually big believers of open source. So this time around we said, okay, like, in order to really serve the community, we have to go open source. And Aperture that you just mentioned is actually an open source initiative from FluxNinja. It's an Apache V2 licensed. You can check out our GitHub. And what that system accomplishes is closed loop, signal processing based reliability automation. And flow control is the first use case we built on top of that. And within flow control, we have two kind of protections built in. One is your rate limiting, as we said, like, if you want to still like prevent abuse from users hitting your website, like, you can have distributed rate limiter that we have. And the second thing that we actually built is pretty interesting. It's a concurrency limiter. So it automatically figures out the capacity of your service at runtime by monitoring its SLOs, and then load shedding or doing a prioritized load shedding and scheduling, and allowing like your critical workloads to still function while you have a partial outage and prevent cascading periods.
This is interesting because you're playing in the realm of observability and modern, cloud native architecture, Kubernetes deployed applications. I would think SREs would be all over this tool to implement it, but why wouldn't an observability platform just natively build something like this into their product, or is that really outside of their realm?
Yeah, I mean, that's a great question. Like, the having spent so much time in the space, I can see that this is kind of an evolution. If you look at in the last decade, a lot of the commercial companies, like if you look at Wiley, New Relic, App Dynamics, Dynatrace, Datadogs of the world, Splunk even, right? So in the last 15 years or so, they have brought to the market a lot of the observability platforms, and these platforms are now also becoming a lot of, like, in a way, commoditized. Like, it's within reach of so many companies now, like, and that sophistication, thanks to open source as well. Now we are seeing like this Prometheus in open source, and scale out Prometheus with Grafana and Chronosphere, and so on. So yes, observability layer was completely missing, that what the community and all these commercial entities have built over the last 15 years or so. So the next battleground for them is controllability. So yes, to some extent this should be in the realm, but yeah, but observability itself is a big use case. Like, if you look at observability, a lot of the times the use cases are debugging. Right? I mean, you still have a problem. You need to figure out root cause, and you want to understand where the performance bottleneck was, and so on. So that's been kind of the traditional, or like a very big use case for observability. But what we are looking at is now controllability on top. Like, when you look at controllability, this is more about real-time response. So more than like going and figuring out what the root cause was, the what Flux Ninja specifically focuses on is like, how do you bring the system to a stable state? Like, can we throw more compute at the problem? Like, you still need observability tools. So in a way, like, controllability will not uh, like alleviate the need to have observability. It builds upon that. It's a layer on top of that, and that's what computer science is. Like, if you look at our last 50 years of computer science and distributed systems, we have just been layering on top of each other, and going and handling more and more scale and doing things in a more scalable way. So this is just another step in this logical evolution, is what I see. So it's not a question of like whether it will happen or not. The thing is that this is going to happen. Like, we have been using scheduling in operating systems. We have been using prioritization in any system you see. It's just a matter of time that it gets introduced to the API and the web scale engineering world.
I see. So being that we're hearing so much these days about SRE burnout, right? I hear that all the time. This is something
Mhm.
that would obviously help them. Um, is this something that would fall in the area of platform engineering? Because there's this whole new topic about how platform engineering is replacing DevOps. We know that's not the case, but the use case around that is platform engineering is a way to give the developers and the SREs the tools that they need for their framework to get work done faster, get to coding faster, get the tool removed faster, and allow that to happen without them having to do everything themselves. Is this something that would fall into that category?
No, that's interesting. Like how people see the role of SRE is a question. And if you're like looking at the history, like this whole term site reliability engineer was popularized by Google when they wrote a book about it, right? And I kind of call that SRE 1.0. Now what we're going to see is now SRE 2.0, and I'll talk more about that. But let's first look at the SRE term, right? So when Google popularized this idea that you have to have software engineers think about reliability and operations, a lot of companies started hiring for that role. Now, what happened is that even though that role got hired, but not the entire job description was copied over from Google. So Google's way of doing site reliability engineering is still very different than what we are seeing in very traditional enterprises. And in a lot of these companies, if you look at the job roles, they are looking at, yes, observability is something they are owning. This is very clear now. They are responding to incidents, so all the incident response and all the tooling around that is something they own. And but on the other hand, if you say, okay, are these engineers going to apply rate limits or any sort of protection? Now that is a question on which team is ultimately going to own that, because right now where I see it is this job role is very broad. So if you have to take this idea and hire at scale, like, I mean, yes, Google can get the best engineers, but this is not something a traditional enterprise can get. We are looking at, if you just look at the job role, the whole breadth is almost like you need a PhD quality person
That's right.
for that role. You know, not just Linux distributed systems, then you're talking about networking and advanced concepts within that. You're talking about complex failure conditions. So you need a lot of breadth and depth in that role. So yes, the tools like FluxNinja can help democratize the practice, but at the same time, this whole idea of platform team emerging is that maybe some other team is needed to take care of some of this tooling, and maybe it's a collaboration where SRE may evolve to becoming a more incident-centric kind of an emergency responder kind of a role, whereas some of these proactive protections and tooling and automation is maybe done by some other team. So we are also waiting and watching. Like, I mean, this is the thing with the industry. Like, we invent new terms. Like, for example, machine learning was a new AI, and now AI has gained popular. So it keeps happening. And the same thing we are seeing in the ops space. So we had IT ops evolving to SRE, and now we are seeing platform engineers, which is kind of DevOps and SRE kind of an hybrid, is from what I'm seeing.
If people want to know more about what you're doing here with Flux Ninja, how can they find out more and how can they contact you?
Yes, so one of the things is, as this is an open source project, so one of the big, um, I think, call to action from our side would be like check out GitHub. We have Flux Ninja Aperture as one of the projects. We have a playground over there that they can try locally. It's a Kubernetes cluster that shows Aperture in action in a demo application that we have designed. And if you're interested, and we do have a cloud solution as well, which takes analytics data from Aperture installations and provides like high cardinality flow analytics, so you can understand quality of experience based on your HTTP requests and your features in the code, and very high cardinality, like slice and dice. You can go into per user details, types of users, and so on, slice and dice at that kind of level with our cloud product.
Awesome. I will make sure that we put the GitHub link and the Flux Ninja website out there, and any other links that you want to share. We'll put those in the show notes on the smcjournal.com. Thanks so much for being on the show. This is an interesting solution, and I'm interested to see how this goes from here, like what type of adoption that you get. And we'll see you hopefully soon. You'll have some more news for us.
That's great, Scott. Thank you for having us here.
Thanks. As I said, we will be sharing all of those links on the smcjournal.com website on this episode. If you are listening to us in audio format, if you'll go to our website, you'll see the visuals that we refer to in this site for the web links and other things. There's some demo videos out there on YouTube that we're going to be sharing as well. So what do you think? What do you think about FluxNinja and automating reliability? Does that interest you? What are other ways that you can do that? Love to hear from you. Here's how you can reach me on LinkedIn and on Twitter. My website is scottmoore.consulting, as well as smcjournal.com. You can always reach out to me by email. This is my email address, at least for right now. We're going to be changing that very soon. And most importantly, if you like this content, please hit the like button and tell me that I'm doing a good job, because that means you're going to get more episodes like this. I got to move over so I'm in the picture again. So thank you again for watching for this episode of the SMC Journal Podcast. This is Scott Moore saying thanks and bye-bye.